Hello everyone. In this video we will see about introduction to robotics. So first, what comes to your mind on hearing the word robotics? So robotics, it conjures the images of machines that can perform tasks autonomously or semi-autonomously. Okay, often with human-like precision and efficiency. And this encompasses a field of technology focused on designing, building, and controlling these intelligent mechanical systems. Okay, so first we'll see what is history of robots. So science fiction has explored the concepts of robots and artificial beings in various plays and movies. For example, Mark Shelley's 1817 novel, that is Frankenstein, the idea of creating artificial life is introduced. Then in 1921, Karel Capek coined the term robot in his Czech science fiction play Rossum's Universal Robots. Okay, so where a robot means a worker or servitude in Czech. Next, Isaac Asimov's famous robot series starting in 1939 introduced the concept of robots governed by his three laws of robotics, okay, which are a set of rules to ensure a safe and ethical robot behavior. So these works have significantly influenced the way we think about and imagine robots in science fiction and beyond. So next, Asimov's three laws of robotics. Okay, so these are like a set of guiding principles for the robots. So robot first law is a robot should never harm a human being, and it must also prevent humans from coming to harm due to its actions or inaction. And next, second law is a robot must follow the commands of humans unless following those commands would lead to harming a human, in which case it must prioritize the first law. Okay. Then third law is a robot should take care of itself to ensure it can keep helping humans, but not if doing so it goes against the first or second laws. So meaning it can't sacrifice a human safety for its own survival. Okay. So these are like a code of ethics to ensure that robots always prioritize the well-being and safety of humans. You could see in the picture as three laws of robotics by Asimov. Next, some of the examples. You can see here as the flute player, digestive duck, and tambourine player. Okay. So here flute player. So it is a famous ancient Greek automation, a mechanical device which could play the flute. Okay, it was one of the earliest examples of a robot designed to produce music through automated movements. Okay. And next is the digesting duck. You could see here in the picture. The digesting duck was this was a 18th century automation, okay, created by this author Jacques D. Vaccanson. So it's known for its ability to imitate the eating and digestion process of a real duck. Okay, so it was a remarkable engineering feat of its time, showcasing the possibilities of automata in mimicking living creature. And next, third is the tambourine player. So similar to flute player, this would refer to an automation designed to play the tambourine. Okay, that is a musical instrument. You could see here in the picture, both flute player and the tambourine player and digesting duck, all the three. Okay. So here, this automations were popular during the 18th and 19th centuries and demonstrated the craftsmanship and creativity of their creators in replicating human-like actions. Okay. I'll show you in video.
If you are running a business where you are the one who's
Sorry,
managing operations, sales,
YouTube. This is a flute player. So producing a music through automated movements. Okay. Next. So these are other examples of Jacquet's loom. Could see in the video. These are some of the examples of automated. So this was the 18th century automation. You could see here. So next, humanoid robot. So I'll show you a video. Okay, you have a Leonardo's robot and Electro and Sparko. Okay, so Electro and Sparko is a humanoid robot along with its animal pet. Okay.
Leonardo's robot, or Leonardo's mechanical knight, was a humanoid. The design notes for the robot appear in sketchbooks that were rediscovered in the 1950s. Leonardo is said to have displayed the machine at a celebration hosted by Ludovico Sforza at the court of Milan in 1495. The robot knight could stand, sit, raise its visor and independently maneuver its arms, and had an anatomically correct jaw. The entire robotic system was operated by a series of pulleys and cables. Since the discovery of the sketchbook, the robot has been built faithfully based on Leonardo's design and was found to be fully functional. The robot is described as being clad in German-Italian medieval armor and is able to make several human-like motions. It is partially a result of Leonardo's anatomical research in the canon of proportions as described in the Vitruvian Man. Thank you for watching. Like and subscribe.
So next is about Electro and Sparko. This is Sparko.
A cigarette.
So this is made in 1940s. Okay. So I could see the evolution of a robot here. Okay, I'll show you a video. So first humanoid robot in 1495 and 1645 is Pascaline. In 1709 is the digestive dog which I have shown. 1865 is the steam man. So this is Electron Sparko. 1938. 1942 is first programmable mechanism. Here Elmer and Elsie. Next 54 is Unimate. So you could see the evolution of robot in this. So NASA's Pathfinder, Mindstorms, all are recent Lego robots. Okay. Asinosa assistant robot. So you could see from 18th, 19th century robot evaluation. So how improvement of automation has been done from 18th century till now. Okay. So this is about the evolution of robots. And next is the classification of robots based on their application. So first, industrial or manufacturing robots. So these robots are like mechanical arms fixed in one place at a factory, and they do repetitive tasks like assembling things. They work really fast and accurately, especially when parts are given to them in an organized way. Okay. And next is about service robots. So these robots are helpful around the house or in places like hospitals. They can do things like cleaning, assist people, or help with exercises for recovery. And next is the field robots. So field robots are like the adventures of the robot world. They can go anywhere and do lots of different things in places where things are not well organized. So they are smart and can handle new situations. And next is the humanoid robots. So these robots look like a bit people and are here to help with things like teaching, entertaining, or taking care of us. They are designed to interact with us, kind of like a friendly companion. Okay. And next is what are industrial robot and service robot. So first we'll see industrial robot. So this is smart machine in a factory. They can do many different tasks. It's like a mechanical arm that can be controlled to move in different ways. So and it's very handy for getting things done in a factory. Okay. And next is a service robot. So these are like helpful assistants. They can work by themselves or with a little help, and their job is to make our lives better. They do things like cleaning, helping us, or even assisting with medical care, but they don't work in factories. Yeah, so these are service robots. And next, so what is a robot? That is according to RIA. Okay, definition of robot is a so it is a reprogrammable multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable programmed motions for the performance of a variety of tasks. Okay. So it's like a versatile goal driven machine that can be programmed to do different tasks. So it can see and understand what's around it, make plans, and take actions. So for example, it can grab things with its mechanical arm or move to specific places, all to achieve a specific goal. Okay. And next, so what mainly robot does? Okay, it has a sensor, controller, and an actuator. So sensor, it gathers information about the environment. Okay, so that is its sensors, and then give to the controller. So control action will be taken by the controller. That is thinking or planning will be done by the controller. Then after which to perform the task, perform the action or work, it will for acting it will be given to the actuator. So its sensor, controller, and actuator are the parts. It senses, plans, and act accordingly. So next, what are the components of an industrial robot? So you have various components as sensors, as I said earlier. So you have sensors, controller, and actuator. Okay, sensors you have different types. That is internal sensor, inside the manipulator will be there external sensors for environment information, gathering environment information, and you have control unit controller, and this sensors accordingly what the depends on the task programming will be done. Okay, so this the components of an industrial robot, how it performs. Okay, you have internal sensors and external sensors, and accordingly depends on the task programming will be done, and by the control, and it is given to the control unit, that is controller, and controller will be the action will be set to the actuator to perform the task. Okay, so next are the classifications of robot. So there are different classes or categories of robots set by the Japanese Industrial Robot Association, JIRA. Okay, so first is class 1 as manual handling device. So robots in this class are operated manually by humans. And next is these class 2 is fixed sequence robot. So these robots follow a predetermined and fixed sequence of actions. And next class 3 is variable sequence robot. So these robots can adapt and change their sequence of actions based on the situation. And class 4 is playback robot. Robots in this class can record and then replay a series of movements or actions. Class 5 is numerical control robot. These robots are controlled using numerical commands, making them more precise and programmable. Then class 6 is intelligent robot. So this class includes advanced robots that can make decisions and perform tasks autonomously, often with the help of artificial intelligence. Okay. So these categories help classify and describe different types of robots based on their capabilities and modes of operations. So this is according to JIRA, JIRA. And next is RIA. Okay, so we have seen RIA definition earlier. So this is RIA classification as Robotics Institute of America, RIA classification. So first is variable sequence robot is class 3. So that is these robots can perform tasks with stages that can be easily changed or modified based on the job requirements. And next class 4 is playback robot. So in this class a human operator guides the robot manually to perform task. And class 5 is numerical control robot. These robots receive movement instructions from the operator in the form of a programmed sequence rather than manual teaching. And class 6 is intelligent robot, that these advanced robots have the capability to understand their environment and adapt to changes in order to successfully complete tasks. Okay. And next classification is AFR, that is Association Francais de Robotique. Okay, you have 4 types. So first in type A, manual handling device or telerobotics. So these robots are manually operated or remotely controlled for tasks involving handling. And type B is automatic handling devices with predetermined cycles. So robots in this category, it performs tasks with predefined and repetitive sequences. And third type, type C, is programmable servo control robots for continuous point-to-point trajectories. So these robots are programmable and can perform tasks by following continuous point-to-point paths with precision. And last type is type D. This is same as type C but can acquire information. These robots have similar capabilities to type C. Okay, so but are equipped to gather information from their environments. So these are classifications of robot. Next, robotic system. Okay, so various components that work together to enable the robot's functionality. You could see here. So first is the base. So base provides stability and support for the entire robot, serving as its foundation. And next is links and joints. So robots typically have multiple links connected by joints, which allow the robot to move and change its configuration. And next is end effector or gripper. This equipped with a gripper or a tool. Okay, is a part of the robot responsible for interacting with the environment or performing the specific task. So you could see in the picture about all the components of the robot. Next is the wrist. So a wrist is a component which allows the robot to manipulate its end effector, providing additional degrees of freedom for precise positioning. And next, drive or actuator. So these are responsible for powering the joints and moving the robot's limbs. They provide the necessary motion for the robot to carry out the task. Okay. And next is the controller. So controller is the brain of the robot, managing its movements, processing sensor data, and executing tasks based on the programming or commands. And next, sensors. So these are used to gather data about the robot's surroundings. Okay, we know that. So this information helps the robot make decisions and adapt to its environment. So these are about the components of a robotic system. And next, we have various robotics terminology. So first, robotic manipulator. So it is an arm-like part of the robot responsible for moving, positioning, and manipulating objects or tools. This like entire robot is the manipulator. Okay. So you have kinematics. So direct and inverse kinematics. So direct is forward kinematics and inverse kinematics you have. So generally kinematics deals with the study of motion in robots, focusing on how different parts of the robot move relative to each other without considering forces or tasks. Okay, so inverse kinematics, this will determine the joint angles or positions required to achieve a desired end effector position and orientation. Okay, and next is the trajectory planning. Okay, so trajectory planning is the uh, path planning. Okay, so you have how a robot will follow the path to perform the task. Okay, so you have various you have degrees of freedom. Okay, what is this degrees of freedom? Is a number of independent directions or ways a robot paths can move. Okay, so each joint typically contributes 1 degree of freedom. You have different terminologies in this. And apart from this, you have sensor fusion, machine vision, artificial intelligence, and machine learning. Okay, haptic feedback is there. Human robot interaction. Okay, this generally focuses on the study of development of interfaces and interactions between humans and robots, which includes safety, communication, and collaboration. Okay, so robotics vision, it includes all those things. Okay, sensor fusion, machine vision, AI, and machine learning, all these things. Okay, so these are about the robotics terminology. Anyway, we will be seeing in detail in further videos. So that is all about the robotics introduction. Thank you.